my competency level assessment to become a journeyman in representation of systems, I will be solving a differential and difference equation. Alright, so this is our differential equation over here. And the first thing that we are going to do is set it equal to 0. Equals 0. Okay, and then x double dot, start out with x equals a e to the st, x double dot equals a s e to the st, sorry, that's x dot, and then x double dot is a times s squared e to the st. And now we get to plug those values in. So 3 times by a s squared e to the st. And then add that to 7 times by a s e to the st. And then plus a e to the st equals 0. And now we do have common factors in here, so we can get rid of an st and a, st and a. So now we're left with 3s squared plus 7s plus 1 equals 0. And then I got my calculator. Now I already solved this quadratic formula because I was practicing this earlier. So I have these values written over here along with my little equation sheet. So s ends up being negative 0.153, and then negative 2.18. So this means that xc is going to equal c1 times e to the negative 0.153 t plus c2 times by e to the negative 2.18 t. So this is our xc. So I will write that up here. Go. And then we have values of s over there, so that's all good. All right. So we can move on to the next part. Just finding xp, which we are going to use xp for 6e. xp will be 6 and there have to be a e to the negative 2t. We replace the 6 with an a because that's what we're trying to solve for to help find our constants over here. So x dot x goes a e to the negative 2t, x dot would equal negative 2a e to the negative 2t, and then x double dot is going to equal 4e to the negative 2t. Alright, and now we plug that back into the original equation. 3 times by 4e to the negative 2t plus 7 times by negative 2ae to the negative 2t, and then plus x is equal a e to the negative 2t, which would equal 6e to the negative 2t. And as you can see, we can get rid of a negative e to the 2t. We want to keep that a though. I need an a right there, and an A right there. We want to keep an A though because that's what we're trying to solve for. So we're with E, and E. So I'll leave this with 12A minus 14A plus A equals 6. So we can see from this right here, we'll get a negative A equals 6, which then translates to A equals negative 6. So go up here to XP. P equals negative 6e to the negative 2t. There you go. So now we have our XC and our XP. So we'll erase some of this. All right, got that right up there. So now we will add them together. So we equal C1 e to the negative 0.153t plus C2 e to the negative 2.18t minus 6e to the negative 2t. All right, so we have this full equation right here. As we can see above, when t equals 0 for x, x equals 4. So 4 is going to equal C1 times e. 1.153 times 0 is just going to be 0 plus C2 e to the negative 2.18 times by 0, and then minus 6e to the negative 2t, and then t is just going to be that 0, right? And then, so 4 is going to equal C1 plus C2 minus 6. So we'll put it up over here, C1 plus C2 equals 10. So that is going to be our first equation that will help us find C1 and C2. Alright. And now we are on to our next one. So we will have x dot is going to equal 0 when t is 0 as well. So we'll take back the original equation. Oh, we actually take the derivative of this original equation because since x dot is the derivative, we'll have to take the derivative of this whole thing, or rx, yeah. So C1, actually I will write around the derivatives. So it's going to be a negative 0.153 C1 e to the negative 0.153t plus, be minus now, minus 2.18 C2e to the negative 2.18t, and then we will do a plus 12e to the negative 2t. And then again, we'll plug in 0 for all those t's. So plug in 0, 0, and 0. So then these will all be 1 right there. So now you just have x dot equals 0.150 equals 0.153 C1 minus 2.18 C2 plus 12. And now we can write our second equation. So 0.153 C1 minus, should be a negative right there, negative 1.53 C1 minus 2.18 C2 equals a negative 12. Right. So C1 is going to be equal to 10 minus C2. So we'll plug that in for this equation down here. Times it by 10 minus C2 minus 2.18 C2 equals a negative 12. Alright, and so we will solve this all out. So negative 0.153 times by 10, negative 1.53, and then it'll be positive 0.153 C2 minus 2.18 C2 equals a negative 12. So we will add together the 0.153. Subtract. So 0.153 minus 2.18 equals negative 2.027 C2 minus 1.53. Subtract those two, and then equals a negative 12. So we will add 1.53 to the negative 12, and then we will divide by the negative 2.027. It's a mouthful. Plus 1.53 plus 1.53, and then divide the whole thing by negative 2.027. So negative 12 plus 1.53 gives us a negative 10.47. And then we take that divided by a negative 2.027. And then for C2, I got 5.17. And I will just double check my math real quick. So negative 12 plus 1.53 divided by negative 2.0. Negative 12 plus 1.53. There we go. Then divided by negative 2.027. All right, we got our C2. So we can erase this. And then we have C1 right here. So C1 is just going to equal 10 minus the 5.17. C1 is going to equal 4.83. And now we can plug this back into the original x equation to make our whole total solution. So, we've got C1 there. I'll write that right there. So x is going to equal 4.83 times by e to the negative 0.153t plus 5.17 times by e to the negative 2.18, and then we are going to subtract that by the xp, which is 6e to the negative 2t. And here is our x equation. And this is the solution for the differential equation all the way back up here, and this is what we get for x. And then I think in the next video, I'm going to be explaining the difference equation, but it will still be a part of the competency level assessment for the representation of systems. I will just do the difference equation in the next video.